Hello students, we're going to do a review video on distance between points using Pythagorean Theorem. I make it right triangles. So today we're going to talk about how to set up and how to shortcut. We're going to do everything. So this is more like a review video. Alright, so we're going to find the distance between point 1, 2 and point 8, 6. And I am going to graph those. And I'm going to do kind of a mediocre job. 1, 2 is about right here. 8, 6 is about right here. Both are located in the first quadrant. I should label our axes here. And right now I'm looking at this, I have my 2 points, and I can see the distance. I'm going to do that in red. And I can see that that's the distance D I want to find. I'm not going to be able to measure it, I can't count it, it's on an angle. But I see a right triangle, and I'm going to draw it here in blue. And I want you guys to see right triangles as often as you can too. So there's the right triangle. And if you're in my class, this is a big step for us. We want to get this every time. But if I'm going to find D, we're going to use Pythagorean Theorem, which says that the hypotenuse squared, is equal to the sum of the legs squared. Point blank, you put the hypotenuse alone, and then you sum the other two sides. And we've been doing a lot of this in class, so hopefully you remember. And again, because of the way the right triangle is done, D will be the hypotenuse. But we have to determine the horizontal length and the vertical length. I do it by looking at the points. I look at 1 and 8, and I say, how far is it from 1 to 8? And everybody, when you say how far or what the distance is, it's always a difference. 8 minus 1, the distance here is 7. On the y's, the vertical run, it's 6 minus 2, it's 4. And now I have set up a problem that I can draw, and I'll do it in a different color. We'll just use Pythagorean Theorem. I have a leg of 7, a leg of 4, and I want the hypotenuse D to be below the length. So when we set it up, D squared equals, using Pythagorean Theorem, right? The hypotenuse is alone, and it equals the sum, the addition of the other two legs squared. Gotta do some math, not 8, right? Not 14. 10 plus 4, 16 plus 49, so 10 plus 49 is 59, add 1 more, 50, add 5 more. How about D squared is equal to 65? Everyone. I don't want you to memorize that it's always a radical or a root. It is, but what I want you to remember is that the opposite operation of an exponent is a radical. And the distance here is equal to the square root of 65. I want to be clear, you see nowhere on the board 7, 4 like a point. That is not happening here. We shouldn't write it anywhere. Okay? What we want to write is and create are the triangles. So let's do one. Another example here, but let's get a cross from quadrant to quadrant with this example. And I took away Pythagorean Theorem, we'll just use it. Negative 3, 2. We should always label our axes. Negative 3, 2 is up here. 1, negative 3 is down here. And again, I can see the right triangle right now, and I want you to too. You're going to see there, and you're going to see that. And I always make mine on the underside. You don't have to, but I always do. So there's the distance, and there's a vertical rise, and there's the horizontal run. And there's my right triangle. I look between negative 3 and 1 for the horizontal, x values. But 1 minus 3, I have an x value of 4. I go from 2 to negative 3, 2 minus 3, 2 plus 3, and I got a vertical distance of 5. And again, D's there. Guys, Pythagorean Theorem, across from the 90 is a hypotenuse, so that has to be alone, D squared equals, and now I do the sum of the legs squared. I'll go 5 squared plus 4 squared. And now, again, not 10, right? 25, not 8. 4 times 4 is 16. Got to square first. We add 25 and 16. It is 41. And you have d squared equals 41. The inverse operation of an exponent is a root. So we take the root on both sides. The square root of d squared is d, which is what we wanted. And square root of 41 is just that, square root of 41. Guys, as you practice this, attached here is a link. All right. I'll do one more quick example, and then there's a link of practice problems. There's 6 at the end. I'm going to shortcut this one now. I'm not going to graph the whole way. I see that it's a distance, and I immediately think to myself, well, I know a distance. Since this is not a slope problem, so I don't care which way the triangle is going. I know I'm going to have a horizontal distance and a vertical distance. So I look at the -4 and 2 first. The big number minus the small number, 2 minus 4. I have a horizontal run of 6. 1 and -1 for the y. 1 minus 1, that's 2. I know the distance is here, and that's d. The distance is always the hypotenuse in between points, so d squared equals 2 squared plus 6 squared. 2 squared is not 4. Oh yeah, it is. 2 squared is 4. But 6 squared is not 12. 6 squared is 36. 4 and 36 is 40. The inverse operation of d squared, to get d is the square root. And I get d is the square root of 40. Everyone, that is not the answer on the ACT, right? Remember, we have to do radical reduction. We haven't done that much in my class currently. So right now you get there, but we should recognize that that can be broken into square root of 4 and the square root of 10, because square root of 4 times square root of 10 is square root of 40. And then I would get 2 square roots of 10 as my simplified answer. All right. All right, there are 6 problems. I'm going to work them. The first 2 here, I'll work by doing a quick graph. All right. And I'm not going to redraw the triangle out. 7, 0 is down here on the x-axis. 3, 7. I'll put it up here. And again, the scale is not that important. I see a right triangle from 3 to 7. 7 minus 3, right? 7 minus 3, that's 4. And then 7 minus 0, that's 7. And again, the distance here is d. Pythagorean Theorem, right? So we set it up. d squared equals 4 squared plus 7 squared. 4 squared is 16, 7 squared is 49. And lo and behold, you'll see this happen a lot with problems. Since the points are close together, you get the same values for distance, even though they're different points. The opposite operation of an exponent is a root. And the answer to this problem is the square root of 65. Okay. On the next one, -2, 0 is, oops, right there. I was going to go in the wrong spot almost. -5, 1. Now again, I am not going to count, guys. I am not going to count. Now you could if you make a great graph. So -5 to -2. Start at -2, -3, -4, -5. It's 3. Do the difference, that's what you'll get. So that's 3. 1 to 0, that's 1. That's d. d squared equals 1 squared plus 3 squared. 1 squared is not 2, right? 1 times 1 is 1. 3 squared is not 6. 3 times 3 is 9. I get d squared equals 10. The inverse operation, the opposite operation of an exponent is a root. And then I get the square root of 10 for number 2. And that neither of these simplify, okay? Because 10 is 2 times 5. No squares. 65, I wouldn't expect you to know this, but it's 5 times 13. You know, we only know the square root of 4, the square root of 9, the square root of 16. We only know our perfect squares. The next four, I'm just going to draw the triangle, I'm not going to graph them. So I know this is distance, so boom. Because that's what the instructions say, not to be confused with midpoint. Distance from -7 to -3. -6, -5, -4, -3. 4. Okay, you can do a difference. The distance from 5 to 7. 2. We have d. d squared equals 2 squared plus 4 squared. Everyone, you can't just type this in your calculator. And your calculator will do 4 plus 16 for you. You should get d squared equals 20. Take the square roots of both sides. Square root of d squared is d, and square root of 20 is square root of 20. Not the answer on the sheet, because the perfect square of 4 times 5 makes 20. Square root of 4 is 2. So again, if you get the square root of 20, you're correct, but it'll simplify to 2 square roots of 5. On number 4, 0 to -5 is a distance of 5. 5 to 4 is 1. d squared equals 1 squared plus 5 squared. 1 plus 25, use your calculator, you should get d squared when you do the sum of 26. Take the square root of both sides. And the only factors of 26 are 2 and 13, besides 1 and 26. But 2 and 13, we don't know the square root of 2, we don't know the square root of 13. So that's the answer. Last two today, and I'll make the screen bigger. I don't know why I didn't, but I'll make it bigger here. And I'll extend it. I'll do blue now. 7 to 2. 7 minus 2 is 5. Now we gotta be real careful, guys. 8 to -7. We should picture 8 to 0, 0 to -7. Guys, that is 15 for distance. So all of a sudden, and it doesn't matter my scale. You notice I made this triangle horribly out of scale. Doesn't matter. Now we set up our equation. D squared equals 15 squared plus 5 squared. 225 plus 25, I get d squared is 250. Take the square root of both sides. And I wanted to make sure we had some of that reduced. This simplifies, all right? That is the right answer if you got there, awesome. In my class right now, that's full credit. Eventually, I want you to see that 25 times 10 is 250, and we know the square root of 25. It is the whole number, 5. So the answer is 5 square roots of 10. Last one, 0 to 3 on the x value is 3. 4 to 8, 8 minus 4 is 4. 3, 4. Everyone, I think this one's worth memorizing. I'll tell you straight up, I know the answer is going to be 5. Okay, it's 3, 4, 5 triangle. We'll do the Pythagorean theorem to prove it. 9 plus 16, 25 equals d squared. Take the square root of both sides. D is 5. Keep practicing, everybody, all right? And again, this is on every test and every quiz.